In today's class, we are going to start with exercise 16.2, question number 1. A die is rolled. Let E be the event die shows 4 and F be the event die shows even number. Are E and F mutually exclusive? Okay. Let me write sample space of rolling a die. They have given a die is rolled. Sample space of rolling a die. Let it be given by S. It is going to be 1, 2, 3, 4, 5, and 6. This is going to be the sample space of rolling a die. E be an event such that it shows the number 4. So it shows the number 4. F is another event such that die shows even number it is shown. So 2, 4, and 6. 2, 4, and 6. Right? Now, we have the sample space 1, 2, 3, 4, 5, and 6. We have event E and event F. E is 4 and F is 2, 4, and 5. The question is, are E and F mutually exclusive? The answer is no, because the elements are repeated, right? Since E and F have common elements, I can tell E and F are not mutually exclusive events. Mathematically, I can write that E union F or E intersection F is not equal to a empty set. This is not equal to empty set. Therefore, they are not mutually exclusive events. If E intersection F or if intersection of T two events is a null set, then we can tell that two events are mutually exclusive events. Question number 2, I think somebody has joined. Let me just check once. Question number 2. A die is thrown. Describe the following events. The first, A. Event A, it can be taken a number less than 7. When a die is thrown, let me start by writing the sample space. Sample space for when a die is thrown, I can write that as 1, comma 2, comma 3, comma 4, comma 5, comma 6. Event A is a number less than 7. What are the numbers which are less than 7? All the numbers here are less than 7. So A is going to be 1, 2, 3, 4, 5, and 6. This is going to be A, right? I can write normal brackets. You need not write a flower bracket. Okay? A is 1, 2, 3, 4, 5, and 6. Next, the second one, B. It is going to be a number greater than 7. Can you get a number which is greater than 7? No, right? So this can be an empty set, or you can tell, you can write it like this. You can write it this way. Next, C is a multiple of 3. What are the multiples of 3 that you can get? Either you can get 3 or you can get 6. These are two are the multiples of the sample space S, which is 1, 2, 3, 4, 5, and 6. D, a number less than 4. What are the numbers which are less than 4? From the sample space, it is 1, 2, and 3. All these numbers are less than 4. E is an event of a number which is greater than 4. If it is greater than 4, then I can write 5 and 6. These are the two numbers which are greater than 4. Next, F, a number not less than 3. A number not less than 3. If it is not less than 3, then it has to be 3 or more than 3, right? So f, I can write it as 3, 4, 5, and 6. This is going to be the value of f. Next, we have to find out in the same question A union B, A intersection B, union C, E intersection F, D intersection E, and all these. For this, let me write down the value of A, B, C, D, and E. Then let me solve the C. So A is given as 1, 2, 3, 4, 5, and 6. This is what I have got. B I have got as null set. It is a null set. I can write it this way or with a symbol. This is not correct. I can write it this way or I can write this. C is going to be multiple of 3, 3 comma 6. Next we have D. What was D? D was 1, 2, and 3. 1, 2, and 3. E was just 6, is it? E. Where is E? 5 and 6. Yes, E is going to be 5 and 6. Okay. Next, we have F. F was a number not less than 3. 3, 4, 5, and 6. 3, 4, 5, and 6. So I have got the value of A, B, C, D, E, and F. Now, A union B. A union B means all the elements in A also I have to write. All the elements in B also I have to write. So the answer here, it is going to be 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Next, A intersection B. A intersection B means all the elements which are common in both A and B. I can see that no elements are common, so I can write it is going to be a null set. Next, we have B union C. Next, E intersection F, D intersection E, A minus C, and so on. So let me solve all these first. B union C means all the numbers which are in B also and which are in C also. It is going to be 3 and 6. E intersection F, it is going to be just 6. D intersection E, all the elements in D and all the elements in E also, common elements. Intersection means which are common, the elements which are common. Union means all the elements in A and B, both you have to write. In case of intersection, only the common elements we have to write. D intersection E, meaning that all the elements which are common in D and E. In D and E, there are no common elements, so the answer is going to be an empty set. A minus C. A minus C means all the elements which are in A minus which are in C. So C has 3 and 6. From A, you have to remove 3 and 6. Upon removing 3 and 6, I will be getting 1, 2, 4, and 5 as the answer. 1, 2, 4, and 5. This is going to be A minus C. Moving on to question number 3. An experiment involves rolling a pair of dice and recording the number that comes out. Describe the following event A. The sum is greater than 8. B. 2 occurs on either die. C. The sum is at least 7. Which of these pairs are mutually exclusive? This is going to be the question. All right. Now, an experiment involves rolling a pair of dice. Rolling a pair of dice. Pair of dice means 2 dice. Whenever 2 dice are rolled, the sample space is given by sample space for dice is given by 6 raised to the power n. Here it is 2 because pair is considered. 6 raised to the power 2, it is going to be 36. It is going to be 36. Now, what are these sets, right? For that, I need to write a table. For that, I need to write a table this way. We need one, two more. I think you are familiar with this table. Let me write this once more. 1, 2, 3, 4, 5, and 6. Here also 1, 2, 3, 4, 5, and 6. From here you can start writing 1, comma 1, 1, comma 2, 1, comma 3, and so on till 6, comma 6. Okay, here it is going to be 6, comma 1, 5, comma 1, 4, comma 1, 3, comma 1, 2, comma 1. Here it is going to be 2, comma 2, and so on. You should fill all this table. This is going to be the sample space for the die when two dices are rolled, meaning a pair of dice is rolled. Now let us start writing our events. Let us consider event A. A sum is greater than 8. When can you get the sum which is greater than 8? 1 plus 1, it is not possible. 1 plus 2, not possible. 1 plus 3, not possible. Any number in 1 is not possible. 1 4, 1 5, and 1 6, because when you add these two numbers, maximum you will be getting is 7. Maximum you will be getting is 7. No number is greater than 8 in this first line. Similarly, I have to check in the whole of the table. If I check whole of the table, then what are the two numbers? When I add them up, I should be getting greater than 8. Those numbers are those numbers are 3 and 6. 3 comma 6, 4 comma 5, 4 comma 6, then 5 comma 6. 5 comma 6 is possible. 4 comma 5, 6 comma 3, 3 comma 6 is taken. 6 comma 3 also I can take. Next, 4 comma 6 is taken. 5 and 5 also I can take. 5 comma 5. Similarly, 6 comma 4, 6 comma 4, yes, 6 comma 4 can be taken. 5 comma 6 is already taken. 6 comma 5, 6 comma 5 is not taken. 6 comma 5 can be taken over here. Then I can take 6 comma 6. So these are all the possible outcomes. When I add two numbers, I will be getting more than 8. The sum is more than 8. So these are all the probabilities for event A. For B, 2 occurs on either side or either die. 2 should occur on either die. So on the first die I can get 2, on the second die I can get 1. 2 and 2 I can get, 2 and 3 I can get, 2 and 4 I can get, 2 and 5 I can get, 2 and 6 I can get. This is going to be for the first die. What if I get 2 on the second die? Then it is going to be 1 comma 2, 2 comma 2. Sorry, 2 comma 2 is already taken, so I should not be considering that. Next, I can get 1 comma 3, 1 comma 4, 1 comma 5, and 1 comma 6. 1 comma 6. Anything else I can get? 6, 6 comma, yes, I can get few more numbers. That is going to be, if I can get 2 comma 4, also I can get 4 comma 2. Also I can get 5 comma 2. Also I can get 6 comma 2. Also I can get 6 comma 2. Anything other than that? Okay, this is not possible. Wait, 1 and 2, sum should be greater than 8, right? No, this is for the B one. Okay, correct. Here this will not be possible because 2 we have to get, right? So here 2 is not there. So these 3, 4, 5, 6, 7, 8, 9, and 10. 10 we are getting for B. Next, for C. C is sum is at least 7 and a multiple of 3. Sum should be equal to 7 and it should be a multiple of 3. So what is a multiple of 3? What are the multiples of 3? 3 and 6 are the only multiples of 3, right? So when I add them up, it should be a multiple of 3 and the sum should be at least 7. It should be at least 7. Let me consider 3 comma 6. When I add 3 and 6, they are greater than 7. 9 is greater than 7. And is it a multiple of 3? Yes, it is a multiple of 3. 3 plus 6 is 9. 9 is a multiple of 3. Similarly, I can write 4 and 5. When I add 4 and 5, it is more than 7. And when I add 4 and 5, I'll be getting 9. 9 is a multiple of 3. Similarly, I can write 6 comma 3 and 5 comma 4. 6 comma 3 and 5 comma 4. These are your possible outcomes for event A, event B, and event C. Yeah, one more. Sorry. Have forgotten one more. 6 comma 6 also you can write, because when you add 6 and 6, it is more than 7, and 6 plus 6 is 12. 12 is a multiple of 3. So these are the possible outcomes for A, B, and C. Now, which pair of these events are mutually exclusive? This is one more question. Okay. Which of these events are mutually exclusive? Right. Now, I can observe that in A and B. In A and B, let me write it this way. A intersection B is a null set, meaning that there are no common elements in A and B. Since there are no common elements, I can write that A and B are mutually exclusive. Mutually exclusive. Next, I can write here itself A intersection B is going to phi A and B are mutually exclusive. Next, B and C. Let me consider B intersection C. There are no common elements in B and C again. So I can tell B and C are again mutually exclusive events. Again, A and C I can consider A intersection B is not equal to phi. Is not equal to phi because 3 comma 6 is there both in A and C. Since we have common elements, I can write that A and C are not mutually exclusive events. They are not mutually exclusive events. This is going to be the answer for question number 3. This is going to be answer for question number